This is our PowerPoint presentation for Project 2 on the Cantilever beam, and this is Team 4, Chris Jones, Drew Fetty, and Sarah Snyder.
In our experimental section of the Project 2, we realized that as we increase the length, the thickness of the bar, the width of the bar, and the material of the bars were made out of, it had an adverse effect on our K constant. To the right, you can see MATLAB code that calculated the C variable by dividing the K constant by the variables which we recorded experimentally of the length, width, thickness, and modulus of elasticity to find our C variable.
These are two graphs generated by our MATLAB code. On the left is the graph that specifically shows the linear relationship between length and vertical force, and on the right is the power relationship between length and stiffness. Two graphs like this were made for each parameter, including width, thickness, and material, and the exponent in the power trend line reflects the relationship.
This table represents our final results for the exponents received from our MATLAB program pertaining to each of the parameters, M relating to the material, N the width, P the thickness, and Q the length, along with C as our constant. For our M value, we got a value of 1.0. Our N value received the same 1.0. For our P value, we got 3.0, and for our Q value, we received negative 3.0, and our final C constant was 0.2577. This summary table is a combination of our predicted loads and deflections, which we determined from our MATLAB program, the actual results that we received by experimentation, and the error calculation from these results. From our first program number, we had a 0.817 inches deflection, and our actual result was 1 inch flat, which had an error calculation of 18.3%. Our second experiment had a predicted deflection of 0.863 inches, and the actual result turned out to be 0.99 inches, with an error calculation of 10.9%. Our third variable had a predicted load of 1,689 grams, and the experimental result turned out to be 1,489 grams, with a calculation of error of 13.4%, and our final variable had a predicted load of 464 grams, and the actual experimental result turned out to be 491 grams, with a 5.5% error.
In Part 3 of Project 2, we had to determine if a given beam could support a given instrument. This table reflects the given instruments and the estimated drag force that they would apply to the cantilever beam.
This slide represents the cantilever beams that we were able to choose from to support the selected instruments from the previous slide. Each of the beams has a different material, dimensions, and costs.
This image is a model of how the cantilever beam and the instrument will be set up. Based on our MATLAB calculations and our experimental data, we are recommending bars 1, 5, and 6. Bar 6 will hold the velocity flow meter, bar 5 will hold the turbidity meter and the pH electrode, and bar 1 will hold the portable sampler and the nutrient meter. Both bars 1 and 6 cost $10 and bar 5 costs $20, making the total cost $40. This is the best choice because these three bars were able to follow the parameter of deflecting no more than 1 inch, while the other bars could not meet up to this expectation.